Hi and Assalamualaikum. So my name is Muhammad HASIF AIMAN bin Muhammad Sawakan Mahilal. My student ID is 20229677 and 47. Program Master of Science Electrical Engineering. My supervisor is Sir Abdul Karim bin Halim. So this is the topic for my research master, which is design of optimized soil DNA sequence alignment accelerator using Burroughs-Wheeler algorithm for environmental DNA, which is what other people call is eDNA, metabarcoding in precision agriculture ecosystem. Okay, we move on to the next slide. So for the introduction, next generation sequencer have a very high demand in bioinformatics due to the low cost and high speed, making possible a new era of medical breakthrough based on personal genome information. In the pursuit to uncover the secret of life, DNA analysis suffered many technical difficulties at first, but recent advances in different sequencing technology have enabled continual production of DNA sequencer from many organisms. To meet the requirement of efficient and accurate short read mapping, many new alignment program has been developed. A fundamental task in human genome sequencing is mapping short DNA sequences, also called reads, which are generated by NGS sequencer to the reference human genome. Many short read alignment tools based on different indexing techniques have been developed during the past couple of years. Amongst them, alignment algorithms such as BWA, SOAP, SOAP version 2 and Bowtie have become increasingly popular because of their superior memory efficiency and support of flexible seed length. The Burroughs-Wheeler aligner (BWA) is one of the most widely used short-read mapping tools. It based on the technique introduced by Burrow and Wheeler. So we move for the next slide. The problem statement for this research is the first specific problem is the NGS or Next Generation Sequencer platform. Currently being developed were diverse and the data that being produced were various of size and read length. Therefore, it will be hard for the biologists to manipulate the different features involved in this algorithm. Burrow-Wheeler transform BWT based on short-read alignment methods is the large data size, and usually the required data size is several times larger than the original reference data. So, in terms of speed, it takes many hours or duration to complete the data processing. As the new generation NGS produce lot of data increase simultaneously, so the current processing power using processor, for example, will take a lot of time to complete it. Okay. So for objective uh, for this research is the first one is to write and simulate hardware coding using Verilog programming. Then implement the Verilog and test the hardware. Besides that, the other objective is to integrate hardware and software. Then test the functionality of the design project. Number 2 is to reduce the alignment time needed to process the data along boost efficiently use the limited bandwidth of the DR3 memories. And the last one is to improve the performance and achieve a high level of accuracy and configurability, while this project also focus to support and keep and finding the features of new alignment algorithm, which is BWA, Burrow-Wheeler aligner. So for project and research milestone, this is the example for of the literature matrix where it divided into 9 important point, which is which we can see this first one is the author, and then the overview for this project, problem statement, objective, scope, literature review on the paper, then methodology, also result and discussion, and conclusion. So by using this method, we can save a lot of time because we sorting all the important point into a specific column. Then for the literature review, currently the literature review divided on three main subject, which is the first one is all the information that are related to the Burroughs-Wheeler transform (BWT), and number two is any papers that were discussing or talking about the bioinformatics, specifically DNA. Then the number three is the FPGA, because at the end of this project, we'll be using the FPGA to simulate the real time hardware. So the progress for literature review will be still ongoing through until the end of research. So this literature review will not stop. It will continue until the research is done. So for the research methodology, it can be divided into 4 stages. For the first one is perform, which is the currently that we've been doing, is perform literature search to find information on Burrow-Wheeler transform sequence alignment. For this literature, it has many comparison between BWT algorithm and also others algorithm that using the short read. So the next is to construct the BWT DNA sequence alignment using the Verilog or HDL programming. Then after that, if the design is okay, then we optimizing the Burrows-Wheeler transform DNA sequence alignment accelerator using quarters prime. And then lastly, if all the design is okay, then we will implement the design on FPGA board. Then we will see how the Burrows-Wheeler transform read the eDNA with speed, in terms of speed, in terms of accuracy, in terms of complexity. We will compare them to the other method. Then this is for now. As for now, this is the Gantt chart from April until July, which we have performed the literature review on Burrows-Wheeler transform, FPGA, and DNA until week 12. Then after the week 12 or 3 months writing the literature review, then I will be prepared making preparation for the defense research proposal, which is on the early September. So for the status of publication for this research is not yet published any paper for first semester. Then the status for thesis writing is only about 10 to 20%. I've been covered the writing from introduction until the literature review only. So for the planning for the next sem is first is number one to finalize the specification of Burrow-Wheeler transform DNA sequence alignment. Then if we find the specification, then we construct the Burrow-Wheeler transform DNA sequence alignment module using Verilog. And then we finding at the same time we will find the DNA database which is the soil DNA. And then the last one we will simulate the functionality of the module using touch band in model sim. So that's all from me. Thank you very much.